Hey class. All right, so today I want to tell you a little bit about 3 different templates or papers or tables or charts or whatever you want to call them that we're going to be using throughout the rest of the semester. Anytime we do a build or a project at this point, we're going to be using our design notebooks. And with each design or each build, you're going to have to create 3 different documents. One is the design brief, one is a decision-making matrix, and then one is a design process solution. So I want to step through what all of those look like, so when we get ready to build, hopefully starting next week, you're not surprised by any of it and you understand how to do all of them. So this first one is the design brief. So here's what the template is going to look like that each of you will use. At the top we have client, then we have the designer, the problem statement, design statement, our constraints, and our deliverables. So let's kind of dissect this so you know exactly what each of these are going to represent and you know how to complete them. So within this slideshow, it talks about the design brief. The design brief is basically a way that we define the problem. So anytime you have a client, like an engineer has a client, so somebody has come to them and said, I have a problem, I need you to help me fix this problem, they're going to create a design brief, and it's going to explain, it's going to be one piece of paper, usually 1 page, and this is a concise document. It's going to identify the client, so who is the person in need of something. It's going to state the problem, that's going to be your problem statement, and then the details are going to be all included on this. So it acts as if it's a contract so that everybody knows exactly what the problem is, how they're going to fix it, what are their limits or their constraints, and then what is the engineer going to deliver to the client when it's all said and done. So the design brief, again, it serves as an agreement between the client and the designer. Here's an example of one. We'll dig into that a little deeper. The client, so it's usually a person, a company, organization. And sometimes in our case, if I give you a challenge, I'm going to be your client. But sometimes I'll give you a challenge that specifically states the client, and that's what you'll use right there in that client box. All right? The designer, well, if you are the engineer and you're creating a build and you are doing a challenge that's been given to you, you're going to be the designer, or your team rather. So everything we do in here is going to be with your team at this point as far as our builds are concerned. So you're going to include your name, but also include your partner name, your team name, because all of you guys are working together. Where is my arrow? Your problem statement. So this is what I really want everybody to pay close attention to. It's going to clearly and concisely identify the problem. In this example, the locker, a messy locker was the problem, and you can read through it to see exactly how they worded it. But it's pretty concise, meaning it's not a very lengthy statement. They summed it up in just a few sentences to just state exactly what the problem is, so the engineer knows exactly, and not too much words, what is going on and what he or she is trying to fix. So here's an example of the good problem statement. Go ahead and read through this. Push pause and read through it so you understand exactly how they worded it. And then here we're going to step into the design statement. So the difference, this design statement challenges the engineer to take action to address the need and to solve the problem. So in this example we're talking through, which is the locker being messy, here's a good example of how they wrote it. Design, model, and test a high school locker organization system that will neatly contain items commonly used and kept at school. So they're basically restating, putting into words what they're about to do, what they're going to do, what the problem is, or what their design is, how they're going to, or rather, what they're going to design to fix the problem. And then our constraints. So our constraints are going to be thought of like guidelines. What are your limits? What are your guidelines? What are your rules? What do you have to follow within this challenge? And they'll always be listed. So for this one, they had 2 weeks to build it. They could only spend $40. And they had a certain size that it had to fit into. Like a locker is like 8 inches by 8 inches by 48 inches. So it couldn't be any flammable materials, and it had to be easy to install. So those were their constraints on this within their brief, within their challenge. And the deliverable, let me see if I can move this guy around. Yep, there we go. All right, so this deliverable is going to be what it is you're going to give to your client when you're finished. So in this case, they're going to include their sketches. They're going to include their models that they were assembling to get to the end point. They're going to include all their technical drawings, their design journal. So that's another reason why engineers keep a design journal, so they can show their client the process, the prototype that they use to fix it, and then the summary of their presentation when they presented the information to their client. So again, the deliverables are the end product. It's what the engineer, designer, and the client decide are appropriate for the design problem. So you're going to sit down and have that made on the front end so you know exactly what your client wants or expects at the end of the process. All right, so there's the design brief, okay? So hopefully you were taking notes on the design brief template that I gave you, and I want you to fill in exactly each of those items, what they are, so when you sit down to do it, you can look back and see the explanation of each of those compartments on that table. All right, so the next one we're going to talk about is the design matrix template. I'm going to move myself around again. Okay, so this is your design matrix template, and I know it's kind of hard, so you may not be able to see all of it. Let me see if I can widen my screen. Okay, so what this is essentially is a way for your teams to decide which idea you're going to use. And we've already talked briefly about this, but I just wanted to show it to you again, so we're not going to go into full detail. Essentially, you're going to score each person's idea based on certain criteria and constraints. So this is a blank one. You'll get to see this whenever we get to our first build. This is the scoring at the bottom, how to score it. So let me flip over to just a little more explanation here. Okay. We're going to take a closer look at it. Can never find the arrows. There they are. Okay, so here is an example of one. All right, so here's how you're going to develop your design matrix. If you see at the top, we put all the constraints in each column. So for them, they wanted to know which one was the most costly, which one was the most complex to build, which one was going to take the most time to develop, and then they have a total column. So each person in your team will have a specific row. So idea number one goes here, and then you're going to score it based on this scoring scale down low, and you score each idea with each constraint, and whichever idea has the most points, that is going to be your idea that you're going to roll with. So ideally, you're scoring them fairly and accurately. You're not getting your feelings hurt because we all have different talent, and sometimes our idea is not the best. So sometimes a person has another idea that's better, and that's exactly why we work in teams. And sometimes it's tough because you feel like you have the best idea, but you just have to have self-control and understand that your idea is not always going to be the winner. All right, so the decision matrix, I want you to understand the definition, and it's used to compare design solutions against one another using specific criteria that are often based on the project requirements. Not often, they always are. So I don't like that word right there. But anyhow, regardless, we're going to carry on. So there's two. That's your second worksheet. Now the third thing we're going to do together. Okay, so I'm not exactly sure where I left off, so we're just going to hit back here. Miss Ahart came into my room, so I needed to have a discussion with her. Anyway, all right, so the design process. So you have it listed right here for you to see, to kind of walk through. And then on the right side, essentially, you're just going to tell me along the way, every step of the way, your work at this step. So this middle part where it says definition, I'm not so worried about, because if you can tell me the work that you did at that step, then I understand that you know the definition of each of those stages. So what I do want you to do, though, for each build is you're going to fill in each step along the way that your team took as you went through this process. And that way I get it and I know that you get it, okay? So that's pretty simple too. So those are the three basic things that I wanted you to understand and have a better idea of what they are. So when we start next week and I hand these sheets out that are going to go into your design book, you know exactly what they are. You've learned about all of them, and you can go back and look at your notes if you have any questions. All right, hope that makes sense. Let me know if you have any questions about it ever.